Welcome to this very first NodeToy tutorial. In this series, I'm going to introduce you to the most common constant nodes as well as the most useful MUT operators nodes that will help you create amazing shaders. Let's get started.
Once the app is open, you're going to be redirected to the home where all your projects are located. Before starting, let's open the main menu and let's change the appearance to night mode. You can also quickly toggle between nodes using Alt 10. Next, let's create a brand new project. Once the project is open, the first thing you're going to see is the master node. The master node is the output of your shader. It can't be deleted, however it can be modified. NodeToy currently supports standard, physical, and unlit master nodes. They correspond to the 3JS standard, physical, and basic materials. Now, to change the name of your project, click on Untitled and let's put a new one here. You can additionally put down a quick description of your material. Let's click Done, and that's it. The very first nodes we're going to talk about are the float and color node. The shortcut for float is 1 plus right-click. This is the simplest node. It's just outputting a floating point number. You can open its preview and change its value. You can also change the minimum and maximum fields. This will add a slider to the node, as you can see now. You can also change the type from constant to property. Property means that later on, you will be able to set this value outside of this shader. If we now plug this node and open the shader output, we can see a float uniform with the name of our property. Next, colors. The shortcut for colors is 5 plus right-click. Let's pick a new color by clicking on the preview. I'm going to pick a pinkish color for now. As you can see, this node outputs an RGBA color. We can connect it to albedo and change it to property. Let's change its name and let's put color albedo. Additionally, let's use this float to change the metalness. A value of 0 would not be metallic, while 1 would be fully metallic. Now, let's talk about vectors. You will find 3 types of vectors. First, the vector 2. Shortcut 2 plus right-click to create it. The vector 3 plus right-click. And finally, vector 4, which is 4 plus right-click. Those are really fundamental. We're going to see how to use them in just a second. To add a node without using shortcuts, you can either click on the search icon and search for the node you are looking for, or you can also directly right-click on the graph. This will open the menu as well. My favorite way is to just press on the space bar, which will toggle the nodes menu. Let's bring up the panner node, which we're going to use now. This node essentially pans the UV texture coordinates according to the inputs. We're going to use the vector 2 to change the speed of the panner. Let's change the x value to 0.5 and let's leave y to 0 for now. Here, x means horizontal speed, while y is our vertical speed. Let's add a texture coordinates node and let's plug it directly into the UV input of the panner node. If we disconnect the speed, you can see the default UV, and if we reconnect the speed, the UV is modified. Let's add a time node. We're going to continuously be panning the texture coordinates with the time. So now that we have this set up, let's bring up a node that takes UV as input. Let's use the checkerboard node. This node basically generated a simple checkerboard pattern. As you can see, it has a few inputs that you can play with. In our case, we can change the frequency to get more squares. We can also change its color. We could plug in a color here, but for now I'm just going to set its internal color value in the sidebar right there. We can plug the output of the node to the emission and see that we're actually panning the checkerboard pattern. If you change the Y direction, it will start panning in both directions. And if you want to change the direction, you can either set those two numbers to be negative or set the timescale input of the time node to a negative value. Let's lower our timescale a bit. This will essentially slow down our time node, like slow motion. Let's set it to -0.5 and save our project. Let's now use the vector 3. Let's move up those nodes. Now, we're going to add a multiply node. Press M plus right-click or search for it. We're going to multiply our checkerboard output with this vector 3, and in this case, this vector will be interpreted as an RGB color vector 3 channels. If we set the Y value to 1, we're essentially multiplying our checkerboard by the green channel. Let's plug the final output in the emission. For our vector 4, we're going to use it in an unconventional way. We're going to use the X, Y, Z, and W components to respectively change the roughness, metalness, opacity, and the vertex offset. However, as you can see, the opacity is currently grayed out. So make sure to select the master node, and where you see render type, change it from opaque to transparent. Let's set the different components. 0.2 for the metallic, 0.5 for the opacity, and let's say 0.1 for the vertex offset. Now, let's connect those to the master and observe the effect. This one for roughness. As you can see, the reflection went away. Make sure to play with different values to see how you influence the final appearance of the object. And then we're going to use 0.5 for the opacity. As you can see, it is now semi-transparent. We can even set a lower value to make it more obvious. Lastly, if we connect the last pin to the vertex offset input, the sphere is offsetted by a little bit. Let's save our work. Okay folks, now let's jump to the last section of this tutorial. Another important node is the pi node. It is outputting the mathematical constant pi, which is about 3.14. You will see it being used quite often in shaders. It comes with a multiplier that multiplies the constant by whatever input you throw at it. In this example, we're going to use it to rotate a texture to a given angle. Let's add the rotator node. This node essentially rotates the UV texture with respect to the anchor point with a time input. In this case, we're going to provide it with our pi node. We don't have to plug in a UV node because the rotator node already comes with a default UV. In more advanced cases, it can be useful to provide your own UV node, for example with different offset or tiling properties. In this case, we don't really need it, so let's just get rid of it. We can either use the backspace key, the delete key, or simply this button here next to the open preview. Next, let's add a vector 2 to change the anchor value. We're going to put 0.5 and 0.5 so that the anchor point will place right in the middle. For time, let's connect the pi node, and you can see our UV has being rotated by 180 degrees. That's great, but let's add a texture. Let's open the Asset panel and choose a texture. Let's go to the Texture Library folder and select a pattern which should make our rotation look pretty obvious. Let's take this one, a simple grid of numbers with different colors. As you can see, as soon as we plug the rotator output in, our texture is rotated. Let's plug the texture output into the emission pin so it's going to be more obvious. If we disconnect the pi node, this becomes even more obvious. Now, we rotated the texture by 180 degrees. However, if we want to change the default angle, let's say we want to rotate by 45 degrees instead, we have to multiply by 0.25, basically 180 divided by 4. This is the end of the first part of this tutorial that covers all the basic constant nodes. Check out part 2 of this tutorial series, which will go over the most common MUT operators and their use. See you there.